Hello guys, if you come across these questions in your incoming phase 101 exam, how are you going to solve them? They are very easy, okay? So welcome back to this channel. In this video, I'll be solving exam based questions from chapter 1 from chapter 1 and chapter 2 of your physics 101. So these are the parts you usually expect questions from, okay? Now let's start with the very first one. I said the dimensional formula for volume elasticity is. So what are they telling us? They're telling us look for a dimension for volume elasticity. Now take note that volume elasticity is also known as bulk modulus. Okay. Yes, bulk modulus. Okay. Yes, volume elasticity is also known as bulk modulus. Okay. Yes. Now, what is the dimension for bulk modulus or volume elasticity? Now, take note that young modulus, young modulus, then as well as bulk modulus, they both have the same dimension as pressure. Let me understand. They have the same dimension as what? As pressure. Now, I may ask, what is the dimension of pressure? Now, remember in our very first class in physics 101, that is under measurement and units, I showed you guys how to look for a dimension of some quantities, right? Yes, I told you guys that in order to look for a dimension of a particular quantity, first of all, know the formula. Okay, yes. Remember, I told you guys that volume elasticity or bulk modulus has the same dimension as pressure, right? Yes. Now let's look for a dimension of pressure. Okay. Now before look for a dimension of pressure, we need to know the formula of what? We need to know the formula of pressure. Okay. Yes. Now, what is formula of pressure? Pressure is usually equals to what? Force over area, right? Yes. Now if you go to this part of the board here, I place some quantities here, okay, and I place their dimension. Now for if you want to know more about dimension and all, you can go to our very first class. Yeah, our very first class on that is in phase 1 that is measurement and units. There you see how this coming back, okay, but this is revision. Okay, now let me be fast. Now you will look at these are the quantities, and these are some quantities, and as well as the dimension, right? Yes. So what is the dimension for mass? Is capital letter M. Dimension for length is capital letter L. Dimension for time is capital letter T. Dimension for acceleration is LT raised to power minus 2. Dimension of velocity is L t raised to power minus 1. Dimension for area is L raised to power 2, right? Yes. Now remember, this is formula for pressure, right? Force over area, right? Yes. Now let's continue. Now, force is equals to what? We all know that force is equals to what? Force is equals to mass times acceleration, right? Then divided by what? This area, right? Yes. Remember, we're looking for what? We're looking for the volume. We are looking for the dimension for volume elasticity, right? Yes. So I told you guys that dimension volume elasticity has the same dimension as pressure, right? Yes. So let's look. We are looking for the dimension of pressure right now. Okay, now let's continue. Now, what is the dimension of us? We are broken down pressure into this form, right? Pressure is equals to force over area. Then we continue. Force is equals to what? Mass times acceleration divided by this guy, right? Divided by this area. Now, what is the dimension for mass? The dimension for mass is what? Capital letter M, right? Yeah. Sorry about dimension for acceleration. Dimension for acceleration is what? Is F raised by what? Minus 2, right? Yes, then divided by what is dimension for area? Dimension for area is what? L raised by 2, right? Yes, okay. Now I've gone into this aspect. Now we done. Let's simplify it further, okay? Yes. Remember, according to mass, when the letter, let's say when the letter is standing alone, it means that letter is raised to power 1, right? Yes. Anything raised to power 1 will give you that same thing. So let's say when A is standing alone, it means that A is raised to power 1. A raised to power 1 will still give you A, right? Yes. So therefore, you find that M is standing alone, right? Yes. It's sending as what? M raised to power 1, right? Yes. L is standing alone, right? It's still sending as what? L raised to power 1, right? Yes. If anything raised to power 1, we still give that same thing. So L raised to power 1 will still give us L, right? Yes. Now let's continue. M raised to power 1, L raised to power 1, T raised to power minus 2, L raised to power 2, right? Yes. Now, according to the law of indices, when the law of indices, when the same base, when the same base, when the same base, let me say, when the same base, when the same base, when the same base carrying are dividing, carrying different power dividing each other, and these indices, when the same base, these are the same base, right? When they are dividing each other, we will take one of the base, then we'll do what we subtract their power. Okay, so when two base, according to indices, there are different laws. Okay, so according to indices, I think the second law, I don't know. Now, that law said that when the same base when they divide each other, we'll take one of the base, right? Then we'll subtract their power, right? Yes. So these two base, they are the same, right? So we'll take one of the base, we'll subtract their power. We'll now do something like this: A minus B, right? Yes. Now let's go back to this place. Okay. Now, if you observe that these two guys, L and L, they are the same base, right? Yes. So what are we going to do? According to this law just now, we'll take one of the base, then we'll subtract their power, right? Yes. So let's continue. So something like this. We now L1 dividing LH power 2. We'll take what? One of the base, right? Take one of the base, then we'll do what? We'll subtract their power, right? So 1 minus 2, right? So don't forget about this M. Then don't forget about this T raised power minus 2. Okay. So let's continue. We have what? M raised power 1. 1 minus 2 give us what? Give us minus 1, right? Then don't forget about your T raised power minus 2. So this is the dimension for what? This is the dimension for pressure, as well as this is the dimension for volume elasticity, which is option D. Okay, yes. So I will tell you guys, I will tell you, and this is what I want to tell you guys. Just know that they will definitely ask you dimension. Yes, they ask you dimension. Let's continue. Let's go further. You see. Okay, so this is dimension for volume elasticity. Also, please take note of all these questions. Okay, and let's continue. Let's continue with the next question. If x refers to distance, u and v refer to velocity, a to acceleration, and t to time, which of the following equation is dimensionally correct? Now, this is under dimensional analysis. Okay. Now, under what is the usefulness of the application of dimension? Then, with the help of dimensional analysis enable us to know if an equation is correct. I don't understand. Yes. How do you know when if an equation is correct? An equation is correct when the right hand side of that equation is equal to when the dimension of the right hand side is equal to the dimension of the left hand side. So that is when you know when an equation is correct. Okay, let me say it again. An equation is dimensionally correct when the right hand side of that equation has the same dimension as the left hand side of that equation. Okay, yes. Now they said which of the following equation is dimensionally correct? Okay, yes. So let's be fast. Okay, now let's start with let me see. Let's start with D. Okay, yes, D, which is, I know D is the right answer though, but let's start with D. Okay, remember this is from what is the equation? V square is equals to U square plus 2A ox, right? Yes, ox is distance. Okay, ox refers to distance or displacement, anyone. Okay, yes. Now, is this equation dimensionally correct? How are you going to know? You will know when the dimension of the this is my left. Okay, so when the dimension in this part is equal to the dimension of this part. Okay, now this is velocity, right? Yes. Now, before I continue, during dimensional analysis, take note that values, this is very important. Values don't have dimension. Values don't have dimension. Okay, very important. Values don't have dimension. Okay, this is very, very important. For example, 2 does not have dimension. 3 does not have dimension. Pi, which is 3.142, does not have dimension. Okay, this is very important. So take note of that one. Okay, values don't have dimension. Now, remember, to know if an equation is dimensionally correct, we need to know the dimension in the left hand side of that equation must equal to the dimension in the right hand side of that equation, right? Yes. Now this is velocity, right? Yes. Now what is dimension of velocity? We know the dimension for velocity is what? LT raised to power minus minus 1, right? Yes, remember velocity is raised to power what? 2. So everything will be what? Raised to power 2, right? Yes, then equals to u is still what? U is initial velocity, u is still velocity, right? So still be what? Lt raised to power minus 1 or square, right? Okay, let me see. Let me take it to this side. Okay, so let's continue. We all know that okay, v square is equals to u square plus 2a(x), right? Now, dimension for velocity is what? L raised by minus 1. Then you remember velocity is in this place, velocity is square, right? So all square. Then equals to velocity again. Velocity is what? The dimension for velocity is what? L raised by minus 1. Remember, all square because of this square. Then plus 2 times, okay, let's continue, times acceleration. What is the dimension of acceleration? Dimension of acceleration is what? L raised by minus 2, right? Then times distance. Okay, distance, displacement, anyone, distance, displacement, they have the same dimensions. Very important. I've told you guys earlier. Then distance, displacement, um length, okay, distance, displacement, depth, there are very many. Altitude, there are very many. Okay, distance, displacement, height, altitude, breadth, all those points, they have the same dimension as length, which is L. Okay, so the dimension for distance is what? Is capital letter L as well. Okay, yes. Now remember, an equation is dimensionally correct when the right hand side of the equation, when the right hand side or left hand side have, when they are, when the dimension here, dimension here is equal to dimension here, right? Yes. Now what is the dimension of this quantity here? It's very easy. So this, let's look at the dimension of v here. Okay, yes. Now L is equal what? Everything is raised to power 2 here, right? So this same thing means that this same thing means L2 t raised to power minus 2, right? Yes, LT raised to power minus 1 all squared means that L raised to power 2, then T raised to power minus 1 times 2 equals minus 2, right? So the total dimension in this place, in this place is what? Is L2 T raised to power minus 2, right? Yes. And let's continue. What about this other place? Here will still be what? This, because of this square, L2 T raised to power minus 2, right? Yes. Then plus, now you see 2 here, right? You see 2. Remember, actually, guys, value don't take dimension, right? So we can neglect it. Okay? Yes. We can neglect it, all right? Yes. So neglect 2. Value don't have dimension. And let's continue. Now we now left something like this. L T raised to power minus 2, then times what? L. Remember, I told you guys that when a letter is standing alone, when letter is standing alone, it means that letter, when letter is standing alone, it means that letter is raised to power what? Raised to power 1, right? Yes. So if you look at it, L is standing alone, yes. So it means that L is power 1, right? Then L, okay, L is raised to power 1 here, right? Yes. So now in this part, if you look at this part, okay, so I'm coming. Now if you look at this part here, this part, L1 T raised to power minus 2 times L1, right? Now this part, look at it here. Let's look at this part. And according to the first law indices, we state that when the same base, when they are multiplying each other, when the same base are multiplying each other, we take what? We take one of the base, we will add their power. Okay, a plus b. Okay, so when the same base, when they are multiplying each other, we will take one of the base, then we add what? We add their power, right? A plus b, we add their power. But when the same base, when they are dividing each other, we take one of the base, we subtract their power. Okay, but when they are multiplying each other, we take one of the base, we add their power. Okay, if you look now, let's check it. Let's take it to this place. Look at this. You find that these two bases, they are the same, right? They are multiplying each other, right? These two bases are multiplying each other, right? What are we going to do? We take one of the base, right? We'll do what? We add their power, right? So 1 plus 1 give us 2. So now times this one, now something like this, right? We now have L2 T raised to minus 2, right? Yes. So everything here will now be what? Will now be L2 T raised to minus 2, right? Yes. So yeah. So now if we continue, we have L2 T raised to minus 2 here, right? L2 T raised to minus 2 here, right? Yes. Now remember, in mass, in mass, A plus A will give us what? When two things, when we add two things, like when we add the same thing, to give us two of that thing, right? A plus A will give us 2A, right? Yes. B plus B will give us what? Will give us 2B, right? Yes, because they are the same. So C plus C will give us 2C, right? Yes. If we look at this place, these two they are the same, right? L2 3 raised by minus 2 plus L2 3 raised by minus 2. If we add them, just like this, A plus A give us 2A. If we add them to give us two of that same thing, right? Yes, A plus A will give us 2 of A. So therefore, L2 3 raised by minus 2 plus L2 3 raised by minus 2, if we add them to give us what? We have what? We have, if we add them, we have 2L2 T raised by what? Minus 2, right? Yes. Okay, remember, numbers don't have dimension, right? Remember, numbers don't have dimension, so neglect these two. You find out that the left hand side of this equation is the same as what? The right hand side of this equation, right? Find that dimension in the left hand side is L2 T raised by minus 2. Dimension in the right hand side is still what? L2 T raised by minus 2. So let's tell you that this equation is dimensionally correct. Apart from that one, look at the options. You find out that these options they are from equations of motion. Remember, we have three equations of motion. V is equals to U plus AT, right? S equals to UT plus half AT square. Then V square is equals to U square plus 2AS, right? Yes, this is the third equations of motion, right? Yes, so without stressing yourself, you can just go there, look for the right equation of motion, look for the because all of them they are coming from equation of motion. So you look for the one that is question that is question of motion, right? Yes, which is D. V square is equals to U square plus 2AS, right? Yes. So the answer is what? The answer is D. Okay, just take note that an equation is dimensionally correct when the left hand side of that equation has the same dimension as the right hand side. Now let's go to the third question, which is question 3. Please take note of these questions. They are very, very important. Very, very. So let me tell you that question in your exam, you expect question from chapter 1 because I'll be solving question from chapter 1 and chapter 2 in this video. Okay. So let me tell you that you will see questions like all this in your exam. That is just a fact. Okay. Let's continue. I said, which of the following give the dimension of the coefficient of viscosity? So they're asking us to look for, because these are exam-based questions. Okay, these are exam-based questions. So they're asking us to look for the it's like give the dimension. They're asking us to look for the dimension of viscosity. Okay, they're asking us to look for the dimension of viscosity. Now remember, I told you guys, the very first thing I told you guys that to look for a dimension of a particular quantity, the first thing you need to know is you need to know the formula of that quantity, right? We are looking for what? We are looking for viscosity, right? We're looking for viscosity, okay? We're looking for this viscosity. So we're looking at the dimension of viscosity. So how are we going to look for the dimension of viscosity? At first, know the formula of viscosity, okay? Yes, to know the formula of viscosity. Okay, so we all know that. Okay, let me just give formula. Okay, formula of viscosity is force multiplied by, I think, let me just derive it. Okay, I'm coming. Velocity gradient. Okay, so remove this. All right, so okay, so the formula for viscosity is force times length divided by velocity times area. Okay, yes. So this is the formula for viscosity. Okay, this is the formula for the viscosity. Viscosity is equals to force times length divided by velocity times area. Okay, yes. So the first thing I told you guys to know when looking for dimension of a particular quantity, know the formula of that quantity. So this is the formula, right? Now let's continue. Now remember, force is what? Force is what? Mass times acceleration, right? Yes, this is length, right? Divided by velocity, then area. If we continue, dimension for mass is what? Is capital letter L. Dimension for acceleration is LT raised by minus 2. Then times dimension for length is still L, divided by dimension for velocity is L raised by minus 1. The times dimension for area is what? L raised power 2, right? Yes. Now what I'm going to do next, we are going to simplify all these things. Okay, let's simplify. Okay, now according to indices, we all know that according to indices, let's start with this part. Okay, now remember, I told you guys that when the letter is standing alone, it means that letter is power 1, right? This one means that L is power 1, right? Yes, when liter is standing, this one means that m is raised to power 1, right? When liter is standing alone, means that that letter is raised to power 1. Any raised to power 1 give that same letter. Okay, so let's continue. Look at this. These two guys are the same base, right? Yes. Remember, according to indices, when the same base, when they are what? When they are multiplying each other, what are we going to do? We will take one of the base, we will do what? We add their power, right? Yes. These two base, they are multiplying each other, right? Yes. So this we will do what? We take one of the base, we will add what? Their power, right? If we add their power, 1 plus 1 give us 2. Therefore, this everything here will not be what? Everything here will not be L raised power 2, right? Yes. You know what I did just now, right? Yes. Now let's continue. Let's go to this down place. Let's go under. Now if you look at it, if you go under, the same thing happens here. Find out that these two bases are the same, right? Remember, when two bases are multiplying, when the same base are multiplying each other, let's say a raised power a now times that's a raised power b. Now, when the same base are multiplying each other, we'll take one of the base, we'll do what? We add their power, right? Yes, look at this one. This is L1 multiplied by L2, right? So what are we going to do? We'll take what? We'll take one of the base, right? So we add their power, right? 1 plus this one has 2, right? Yes, so everything will not be L raised power 3, right? Yes. So everything here will not be what? L raised power what? L raised power 3, right? Yes. So what next are we going to do? Now, let's simplify further. Okay, if you look at it's all of everything is just a bind indices. Look at these two. L raised power 2, L raised power 3. These guys are the same base, right? According to indices, when the same base are dividing each other, we will take one of the base, we will do what? We will subtract their power, right? Yes, when they are dividing. But when they are multiplying each other, we will take one of the base, we will do what? Add their power, right? Yes, but when they are dividing, we will take one of the base, we will subtract their power, right? Yes, look at this one. L2 is dividing L3, right? So what are we going to do? We take one of the base, we subtract their power, right? Yes. So L2 dividing L3. We take one of the base, we do what? Subtract their power. 2 minus 3. Everything will be what? 2 minus 3 give us what? Minus 1, right? Yes. So everything here will not be what? Everything here will not be minus 1, right? Yes. Same goes for this. This guy is still raised power minus 2, t raised power minus 1. They are the same base, right? Yes. So what are we going to do? This when the same base, when they are dividing each other, we will take one of the base, we subtract their power, right? Yes. So we subtract the power minus 2 minus subtract their power, right? Minus then minus 1, right? Minus and minus will give us plus, right? So now we plus 1, right? Yes. Now something that is t. Now minus 2 plus 1. Okay. So minus 2 plus 1 will give us minus 1, right? Yes. So give us minus 1. So everything will not be what? Everything will not be minus 1. So everything here will not be what? Will not be what? Will not be t raised power what? Minus 1. So this is dimension for viscosity. M raised power 1, L raised power minus 1, t raised power minus 1. So let's look for it. That would be A. This M means that M is raised power 1, right? L raised power minus 1, t raised power minus 1. So the answer is A. Okay? Yes. Now let's continue with question 4. Okay, so these questions, they are very, very easy. Okay, yes, they are very, very easy. Now question 4. Okay, for question 4, they say so these are the places we expect question from. Dimension, that is from chapter 1. Dimension. Then let's just continue. Okay, now let's continue. Question 4. A car travels at a constant speed of 15 meters per second. Okay, 15 meters per second. How many miles does it travel in 1 hour? What are they telling us to do here? They are telling us to convert this speed, 15 meters per second. They are telling us to convert it from 15 meters per second to what? To mile per hour, right? Yes, this is another conversion factor. It is conversion factor. Okay, so they said a car travels at a constant speed of 15 meters per second. How many miles does it travel in 1 hour? It's very easy. Okay, they said what are they telling us to do? They said we should convert this 15 meters per second to miles per hour. So it's very easy. Okay, yes. Now we call in our very first class, I gave you guys important notes. I told you guys that 1 mile is equals to what? 1006. This is the conversion factor for length. Okay, this is conversion factor for length. Okay, yes, conversion factor for length. 1 mile is equals to 1610 meter. 1 kilometer, well, we all know that one is equals to 1000 meter. 1 foot one we call feet. 1 foot is equals to what? 0.305 meter. And 1 inch is equals to 0.0254 meter. So take note, like just memorize these things, they are very important, okay? Just know that one man, because they'll bring conversion factor in your exam, they'll surely bring it. Okay, they said, okay, with the antenna to convert from meter, the antenna to convert 15 meter per second to mile per hour, right? Yes. So now let me teach you how to do it, okay? Yes, let me teach you how to do it. Now you know that 15 meter per second it means that this same thing means that 15 meter is dividing what is dividing 1 second, right? Yes, it's dividing 1 second, right? Yes, if 15 meter divide one, anything divide one will give that same thing. So if 15 meter divide 1 second, we have what? We have 15 meter per second. I don't understand. So the 15 meter per second means that 15 meter is dividing 1 second, right? Yes. What are we going to do? So this is the very first step, okay? Do it like this. Then what are we going to do next? We'll convert this 15 meter to what? To mile. We'll convert this 1 second to hour. Then when we get our answer, let's say when we get our two answer, we divide. When we get our answer, we divide them. We divide them. I don't know if you understand. Okay. Yes. So at first, break it down into this 15 meter dividing 1 second, right? We convert this 15 meter to mile. Then we convert this 1 second to what? To hour, right? Yes. Now, how are we going to do that? It's very easy. Okay. So how we do that is very easy. Just go to this conversion factor. We all know, look at the conversion factor, okay? Yes. Now, look at it. We want to convert from 15 meter to mile, right? Yes. Now look at it. We use conversion factor relating to mile and meter, right? Yes. Okay, mile and meter, okay? How we do that? It's very easy. Just do like this. You say, okay. You say, if I'm coming, okay, if 1000 system meter is equals to how many mile? 1 mile, right? 1 mile, right? Yes, 1000 system meter is equals to 1 mile, right? So you want to convert, then you do like this. Okay, if 1000 system meter is equals to 1 mile, then 15 meter will equals to what? An x mile, right? Yes, so we want to convert 15 meter to mile, right? Yes, what are we going to do? Cross multiply. So 1 system multiplied by s will give us 1 system s. Then it's equals to 1 times 15 to give us 15, right? Yes, so what I'm going to do is divide both sides by 1 system, right? So 1 system, this one will cancel this. So s will now be equals to, so 15 divide 1000 system. Okay, so 15 divide 1000 system will give us 0.009 okay, so approximate 0.00932, okay. So our answer was 0.009, okay, 0.00932, okay. Yes, so therefore we are successfully converted from what? 15 meter to what? To mile, right? So 15 meter, we converted 15 meter to what? To 0.00932 mile, right? Yes. So we have converted from meter to what? To mile. So let's tell you that 15 meter is the same thing as what? 0.00932 mile, right? Yes. So now let's do time now. 1 seconds. Want to convert 1 seconds to what? To hour, right? Yes. Remember conversion factor for time. Remember, okay, remember 1 hour equals to 3600 seconds, right? Yes, 1 hour is equals to 3600 seconds. So we'll do something like this. We'll say if 3600 seconds equals how many hour? 1 hour. Because there are 3600 seconds in 1 hour, right? Yes, if 3600 seconds equals to 1 hour, then 1 seconds equals to what? An x hour, right? Yes, equals to an x hour, right? It's what I'm going to do, cross multiply, right? So 3600 multiplied by x give us 3600x. 1 times 1 will give us 1, right? Yes, what I'm going to do, divide both sides. We're looking for x, right? Divide both sides by 3600. Okay, so this one will cancel this. So x now equals to 1 divide 3600 give us what? Okay, so let's do it. So 1 divide okay, 1 divide 3600 give us 0.0002777. Okay, so I approximate. So 0.0002778. Okay, so let me look at. So everything will not be equal to what? 0.000. Okay, then 278. Okay, so one from 1 seconds is, so they are what? They are, okay, so converted from 1 seconds to what hour? So 0.0002778 hours. Very small. So that's saying that they are 0.0002778 hours inside 1 second. That is, I don't know. Okay, let's continue. Okay, so we have successfully converted from 50 meter to mile. Successfully converted from seconds to hour. What are we going to do next? We will divide our answer, right? Yes, remember they said how many mile does it travel in 1 hour, right? So convert, you want to convert 50 meter per second to what? To mile per hour. The very first thing you break it into, the very first thing you did, we break it into like this. You say 50 meter per second means that 50 meter is dividing 1 second, right? Yes. Then we converted 50 meter to mile, converted this 1 second to hour, right? Yes. So what we have done that now, we divide what we got. So let's do it. Let's divide it. So 0.000, okay, 0.00932, then divided by 0.000 278. So if we do everything, we have 33.525. So the answer is what? Our answer is 33 points. Okay, let me approximate 53 mile per hour. Okay, yes. So this is the answer. Okay, so a car travels at constant speed of 15 meters per second. How many miles does it travel per hour in 1 hour? So this is in mile, 33.53. 33.53 miles per hour. So this is how you do it. Okay. Yes. So you see question from conversion factor. Okay, something like this. Okay. Yes. Now let's move to the last part. Question 5. Which one of the following has the same dimension as time? Okay. Yes. So it's very easy. Please don't forget about all these things. Okay. Now before I continue, there's one thing I want you guys to do for me. Okay. So please, if you have not subscribed yet, please subscribe. Okay, it's very important. Okay, do that. Okay, now, okay, so let's continue. All right, they say that's question 5. They say which or one of the following has the same which one of the following has the same dimension as time? Okay, so this still under dimensional analysis. Okay, so let's do it. Okay, so these are the options. So these are usually exam based question. Okay, yes. Okay, so question 5. They said which one of the following has the same dimension as time? So the right answer here is B. Okay, yes, root 2x over a. So this is the answer. Okay, now let me show you where it has the same dimension as time. What is dimension for time? Dimension for time is capital letter T, right? So if we simplify this, we still have what? T. Okay, let's simplify it. Root 2s divide a. Okay, remember what is dimension? This, remember, value don't take dimension, right? So forget about this 2. Okay, yes, value don't take dimension, so forget about this 2. Now let's continue. What is dimension for distance? This is distance or displacement or length. Remember, I told you guys, distance, displacement, depth, breadth, they have the same dimension as what? Length, which is L. Okay, so dimension for a distance is what? Capital letter L, right? Don't forget about the square. Now about acceleration. Dimension for acceleration is what? Is L T raised to power minus 2, right? Yes. Now remember this 2, when a number is letter stand alone, it means that letter is power 1, means that letter is power 1, right? Yes. Now these two base, remember, according to indices, when the same base, when they are dividing each other, we take one of the base, we do what? Subtract their power, right? Yes. So we take one of these base, one of the base, we subtract their power, 1 minus 1, right? 1 minus 1 give us 0, right? Yes, give us 0. Anything raised power 0 give us 1, right? Yes. So everything here will be what? Everything here will be what? Everything here will be 1, right? 1 divided T raised power minus 2, right? Yes. Now, according to, I think it's still indices. When the letter, okay, when the value is when a number or when the letter is raised to power a negative, raised to power a negative value, for example, when the letter is raised to power a negative value, it means that you see something as what 1 divide a raised power 2. Okay, yes, it means it's something like this. A raised power minus 3 is something as like you see something as 1 divide a raised power 3. Okay, b raised power minus 6 is something as what 1 divide b raised power 6. Okay, yes, look at this one, t raised power minus 2. So it's still something as what 1 divide t raised power 2, right? Yes. So if one something like this, 1 of them 1 divide t raised power minus 2. Okay, according to mass, you see under this one is dividing this one is dividing this. According to mass, this one comes up, right? Yes, it will come up. So now be times t square, right? Yes. So 1 times t square will still give us t square, right? Will still give us t square, right? T square divided 1 will still give us t square, right? Yes. Now we're not left with what? The square root of t square. We're not left with the square root of t square. Now this 4 will cancel square root. We'll not be left with what? T, right? Remember, I told you guys that we must get t, right? So the answer is that's to tell you that 2x divided by the square root of 2x divided by acceleration has the dimension as time. So the answer is what? B, root 2x divided a. Now let's move to chapter 2, vectors. Okay, so this will tell you that in chapter 1, where the ask question from chapter 1 is they ask me dimension, conversion factor. There you just it, dimension and conversion factor. They tell you to look for dimension of this quantity, which of these quantities and which of this equation is correct. Conversion factor, convert this to this, convert 20 meter per second to mile per hour, and so on. Okay, so please take note of all this. That is very important. Okay, now and also I also need you guys to do something for me. Please don't forget to subscribe. Okay, this is very important. Now let's move to the next part under this, which is let's move to the next. Let's move to vectors. Okay, yes. Now let's continue with the next part. Okay, so this part is these questions, they are from chapter 2, which is vector quantities. Okay, so these are questions, these are exam based questions. Okay, so apart from taking notes of this question, the most important thing is know how to solve them. Okay, it's very, very important. Okay, if you look at previously under chapter 1, you find out that where we ask the question from is from dimension. Yes, dimension, then conversion factor, then dimensional analysis. Okay, so this from this part 2. Okay, that means vector quantities, right here, chapter 2. Okay, so these are the questions you're going to expect. So just know how to solve them. Okay, yes, so know how to solve them. Okay, yes. Now let's start with this question. It's very easy. This one is, most of them are from resolution of vectors, so it's very, very easy. Okay, so they said a boy starts from his room and walked 20 meters south. Now before I continue, let me tell you guys something. Okay, so we all know that this is the 4 cardinal points, right? Okay, this part is known as the north, this is known as the east, this is known as the south, this is known as the west, right? Yes, remember in our previous class, then another vector, I told you guys that east is okay, so before then, this is not east, right? This is not east. This is northwest, right? This is southwest. Then this is southeast, right? Yes. So previously, I told you guys that east, the angle of east is 0 degree or 360 degree. Okay, I want to be fast. Then for northeast is 40 degree. Okay, all right, so let me write it to the side now. Okay, east has 0 degree or 360 degree. Okay, northeast, please take note, it's very important. Northeast is 40. I say 40 degree, 45 degree. Okay, north, the angle of north is 90 degree. North is 90 degree. Then just keep on adding 45. And northwest, 45 plus 90 give us 135, right? So northwest is 135 degree. West is, we all know that one now. One is 180, right? So 45 plus 135 give us 180. So west is 180 degree. Southwest is add 45 to it. Okay, Let me add it. 180 plus 45 is 225. Alright, so 225 degree. 225 degree. Then south, we all know south. South is 270 degree. Then southeast is 315, right? Let me see. 270. We just add 45 to 270. Coming 270. I'm coming. 270 plus 45. Yes, that is 315 degree. Okay, 315 degree. Okay, so that is very important. Now let me clean this part. So please take notes. Okay, take note of this. Let me write it again. East is 0 degree or 360 degree. Okay, from the remember we make angle with reference to the positive s, right? Yes. So east is 0 degree or 360 degree. Northeast is 45 degree, and north is 90 degree. Then northwest is 135 degree. Then west is 180 degree. Then southwest is 225 degree. Then south is 270 degree. Then southeast is 315 degree. Okay, so please take note of all these. Very, very important. Okay, very, very important. Very, very. Just know them. Okay, yes. So east is either 0 or 45 degree. Add 45 to 0, we have northeast 45 degree. Add 45 to 45, we get 19 north. So just take note of all this. Okay, so please before I continue, okay, so please make sure you have subscribed, okay, because it's not easy at all. Okay, so please support us by subscribing as well as like the video. Okay, please and please subscribe. Okay, so let's continue. So just take note of all this. Okay, now let's go back to the question. I said this is under resolution of vectors, so it's very easy. Just divide it to y and x. Okay, you know that the y-axis is always sine, the x-axis is always cos. Okay, so it just let's continue. They said a boy start from his room and walk 20 meters south. So you have to do it like this, right? Remember, just take note of all these angles. Okay, yes, no, you need to know that. Take note of all these angles. Okay, so remember why the y-axis is usually sine. Okay, y-axis is usually sine, then the x-axis is usually what? The x-axis is usually cos. Okay, so y-axis, let me split it way. Anyway, so y-axis, x-axis. Okay, y-axis is always sine, x-axis is cos. So they said a boy walk 20 meters south. Now we'll do it like we say, okay, under this y, 20, then we'll put sine. Now south is what? South is 270 degrees. So you do like this, 270 degree. Then plus, then go to x. In x, we do something like this. 20, we put in place of, we'll now put cos, then 270. Okay, continue plus. Now let's continue. Let's say, okay, the boy walked 20 meters south. Do you know why I put? Remember, south is what? The angle. So you put 20, then sine. The angle is what? South is 270 degree, right? Yes. So let's continue. Then turn and walk 50 meters in the direction of 30 degree northwest. So you do like this. In 50 sine. They said in the question, they said 30 degree, right? So 30 degree. Okay, then go here plus. Go here, do 50 cos 30 degree. Okay, yes, let's continue. Okay, finally, he walked 30 meters directly north. So plus 30 sine. Now, north is what? 90 degree, right? Yes, then plus you go to this S part. And do that, you know, something like this 30 cos what? 90. So yes, they said find the magnitude of the resultant displacement. The resultant displacement from this. It's very easy. Add this one, get our x, we get our y. Then look, let's add all this one. 20 sine. Remember, make sure your calculator is in degree. Okay. Yes, make sure your calculator is in degree. Very important. Okay, let's do it. So 20 sine. Let's go 20 sine 270 plus 50 sine 30 bracket close, then plus 30 sine 90. So our y is what? Our y is 35. Okay, what about our x? Let's get our x. Let's do it. Okay, so let's do this part. 20 cos 270 plus 50 cos 30, then plus 30 cos 90. So we get 43.3. S is what? 43.3. Okay, what are we going to do next? So I've gotten our Y, we're going to go to our S. So what are we going to do next? Pythagoras theory, right? Which is R is equals to bracket open S square plus, Y square plus S square, or A square plus B square. Anyone, we can use any letter, okay? So R equals to root Y square plus what? Plus X square, right? Now let's continue. R equals to root. Our Y is what? 35, right? All square. Then plus X is what? 43.3, right? All square. So if we take everything, we get our the resultant. So let me just be fast. Let me do it straight with calculator. Okay, so root, square root bracket open, 35, but then bracket close, square, then plus bracket open, 43.3, bracket close, all square. So our answer is 55.68. Okay, so our answer is 55.676. So let me approximate 55.68. So our answer, everything what? Okay, our answer, everything is okay. So everything, our answer is 55.68 meters. So this is the answer. So it's very easy. Look for 55.68. So that is D. So yes, this is resolution vector. It's very easy. Okay, so the answer is D. Now move to the next question, which is okay. This one down question 7. Okay. Yes, question 7. Let me continue. Question 7. So it's still, I think question 7 is still the resolution. So let me see. Okay, question 7, they said 446 is still resolution. 446 of magnitude 15, 10, 5, 20 act on a particle in the direction which makes 20 degrees with each other. Find the resultant in magnitude and direction. So it's still very easy, okay? So let me explain. Okay, they said 446 of magnitude 15, 10. So, okay, 15, 10, 5, and 20 act on a particle in the direction which makes 30 degrees with each other. Let me remember, we start angle from what? We start from the positive x axis, right? Yes. So the 4 forces of magnitude 15 degree usually is at the east, right? Then continue. They said each of the forces are 30 degrees to each other. Look at it, which makes 30 degrees with each other. So there are 4 forces. So these 4 forces, they make 30 degrees to each other. So from here, from 50, this is 10 degrees, this is 10 Newton, right? This is the second force. So the forces between each of the 4, the angle between each of the forces is 30 degrees. Then there's the third force is where is that force? It's 5 Newton, right? 5 Newton. Then the angle between this one and this will still be what? Will still be 30. Okay? Yes, the last one is 20. It's 20. Oh my god, come in. 20 Newton. Then between these two, the angle is what? Is 30. Right? Yeah, so this is what they are telling us. They're telling us that 4 forces act on a particle in direction which makes, so there are these 4 forces act on a particle, and these 4 forces they are 30 degrees within, like, to each other. Okay, yes. Now let's continue. Now you see this. Now you find out that, remember, this is very important, very very important. Remember, when forming an angle, make reference in forming an angle, make reference to the positive s, the positive x axis. Positive x axis is very very important. Okay, we want to form an angle from the positive x axis. Okay, remember, this is positive x axis, right? Yes, 15. Okay, now from 15 to 10 degrees to 10 Newton, the angle between, so this 10, so remember, we make reference on the s, from s, right? Yes. So now look at it, we make reference to the, must be from s axis. I think we are saying must be reference to positive s axis, it must be from positive s axis. So from here to here is how many degree? It's 30 degree, right? Yes, must be from the, like, it must be from the positive s axis. Okay, from here to here will be what? From the positive s axis to this force, the angle is 30, right? Yes. Then from the positive s axis to this other one, what is the angle? The angle will be 60. Look at it, 30 plus 30. I don't understand. So this one, because we look at it normally, this force 5 Newton and 10 Newton. This 5 Newton was inclined to at 30 degrees to what? To this to this 10 Newton, right? Yes, but that's not the real angle, because why? When we are forming an angle, we make reference to what? From the positive verse, we make reference, we draw it from the positive verse. Let me understand. So you draw it from the positive verse, we found out that 55 degree, this 5 Newton is inclined at what? At which angle? At terminal angle. So 30 plus 30 is 60, so 60 degree. Let me understand, yes. Then what about this one? If you draw from positive verse, you draw to the force. Found that 30 plus 30 plus 30 is 90. Let me understand. So let's tell you that this force is inclined at 30 degree to the 90 degree. 30 plus 30 plus 30, that is 90. So this force 20 Newton is inclined at angle 90, from the reference from the positive verse, right? Yes. What about force 5? Force 5 is inclined at what? If you look at it from force 5, if we draw from positive verse to force 5, draw from positive verse to force 5, found that the angle is what? 30 plus 30 is what? 60 degree. Let me understand. What if we draw, then what about force 10? If we draw from positive verse to this force, draw from positive verse to this force, positive verse is what? Is 30 degree. Okay? 10 Newton is what? 30 degree. Okay? 90 degree. What about this other one? 15 degree. What about this force? 15, and the force 15 is equivalent at 0 degree. Remember, east, I told you guys, east is 0 degree or what? 360 degree. So it's 0 degree. Okay, yes. So we have successfully analyzed the forces and successfully analyzed the angles of these 4 forces, right? Yes. Now what are we going to do next? We look for their resultant and direction. So it's very easy. Okay? Yeah, it's very, very easy. So that's just it. So we have analyzed them, right? Now the solution look for what? Their resultant in magnitude and direction. It's very easy. So according to what we did earlier, y axis, then what? S axis, right? Yes. Simple. Let's continue. Now we do it in y. Everything, remember, in y is always sine, s is always cos, right? So we do like we do 20 in y, we do sine 90, right? Y in s be 20 cos 90, then plus in y will do what? 5 sine what? 60. Y will now be plus 5 cos 60. Very easy. That's a good resolution. Plus then there will be 10 sine what? 30. Y will be what? 10 cos 30 degree. Then this other one, 15 sine 0 degree, right? So it's at the x-axis. Then this other one will be what? 15 cos 0 degree. Yes, look at our s. Very easy. So let us do it straight, okay? Make sure your calculator is always in degree, okay? When doing all this one. So it will be 20 sine 90 plus 5 sine 60. I'm coming. Plus 5 sine 60. Then plus 10 sine 30. I'm coming. Plus 10 sine 30. Then plus 15, right? Sine 0. So everything here is our y is what? Our y is 29.33. What about our x? Let's do it. Okay. So our x 20 cos 90 plus 5 cos 60 plus 10 cos 30, then plus 15 cos 0. So everything here is our x is 26.160. Okay, we are getting our x, we are getting our y. What are we going to do next? Yes, we're looking at the resultant. So it's very easy. So arrow is equals to root y squared plus what? X squared, right? Yes. So continue. Our y is what? Okay, and we know our y already, right? So let me expand it. Okay, so arrow is equals to root y squared plus x squared, right? Yes, we continue. Our y is what? Is 29.33, right? So all square, then plus bracket open. Our s is what? 26.160 all square, right? Yes. So let's see the square root of everything. Let me just be fast. Let me use calculator. Let me do it straight to calculator. So square root bracket open 29.33 bracket close all square, then plus bracket open 26.160 bracket close bracket close all square. So my answer is 39.3. So the resultant is what? 39. Okay, our resultant is what? Let me change the marker. Okay, our resultant is 39. Okay, yes, we got our resultant 39 Newton, right? Yes. Are we done yet? No, we are looking for what? We want to look, they say look for the magnitude. We are looking for the magnitude of the resultant. I want to look for a direction. Okay, to look for a direction is very easy. Okay, this is the formula. Look for a direction. Okay, yes, look for direction. Okay, let me just tell. I'll tell you guys something. Okay, so we know that our resultant is what? Our resultant is 39, right? Yes. Look at it. Our y. Do you see minus? Our y is positive, right? If you observe, our s is still positive, right? Yes. You didn't see any negative when we solve it, right? Yes. So our resultant is 39. Okay. So I want to tell you guys something quickly. Okay. So before we look for the direction. Okay. Now this is the four quadrants, right? This is quadrant 1, quadrant 2, quadrant 3, then quadrant 4. Remember, this is positive x, this is positive y, this is negative x, this is negative y, right? Yes. So when your y and your x are positive, the resultant will be in what? The resultant will be in the first quadrant. Then when your y is positive and your x is negative, the resultant will be what? In the second quadrant. Then when your x and your y is negative, that is when you do when you look for y, look for s. Those normal angle, you look for y, look for s. Find that your answer is not negative, your y is negative, x is negative. Your resultant is what? Is at the third quadrant. Then when your x is positive and your y is negative, your resultant is what? Is at the fourth quadrant. Okay? Yes. Now apart from now to look for a direction of the resultant when it is at the first quadrant, it's very easy. To look for a direction, to be theta is equals to inverse of shift tan y over x. Very important. Now when the resultant is at the second quadrant, to look for the direction of the resultant, to not be what? To not be 180 minus tan shift tan x y over x. Okay, let me clean this one. Okay, shift tan y over x or inverse y over x. Okay. Now when your resultant is at the third quadrant and you have to look at the direction of the resultant, it's very easy. It will be 180 plus the inverse of tan y over x. Then when your resultant is at the fourth quadrant, look for the angle to be 360 minus 360 degree minus the inverse of y over x. Yes. Now if you look at this question we are doing, both of our y and our x, they are positive. So the resultant lies in the first quadrant. Now they ask us to look at the direction. We just use this. Theta is equal to inverse y over x, right? Yeah, so I've cleaned it already. Oh my goodness. I've cleaned our y, I've cleaned our s. Okay. Let me see. Okay, okay, yes. Alright, so I still have it in my calculator here. So we have to look for the inverse of y and let's go the inverse of y and x. Okay, so remember our y was our y was 29.33, our x was 26.160, right? Both of them are positive, right? So we want to look for the angle of the resultant. So we are going to the resultant to be 39, the magnitude of the resultant to be 39. Now I want to get the angle. So since y and x are positive, it lies in the first quadrant. Resultant lies in the first quadrant. The direction of the resultant. To look for the direction of the resultant, because like theta is equals to inverse y over x, right? Yes, what is our y? Let's look for it. Go to your calculator. Let's look for it, okay? So our y is what? Our y is 29.33. Our s is 26.160. So let's look for the inverse of this one. So just go to the calculator, press shift then tan, then 29.33. You can just divide it, okay? Okay, let's divide it first. Okay, 29.33 divide 26.160. We get 1.121. So then take 1.121. So take the inverse tan 1.121. So we get 48. So the angle of the resultant is what? Our direction of the resultant is 48. So the direction of the resultant is what? Is 48. Okay, 48 degree. So let's look. Okay, so our answer will be A, 39 Newton. 39 Newton and what? 48 degrees. So the answer is A, So it's very easy, okay? Yes, now let's do the next question. Let's do the next question, which is question 8. Let's do question 8. Okay, so in question 8, they said this one is just easy. An object moves from 4 meter north, then the object moves 4 meter north, 4 meter north, then 3 meter east. This is north. Okay. They said, what is the distance traveled and displacement? It's very easy. Now, distance is a scalar quantity, displacement is a vector quantity. To get scalar quantity, we just add them together. So they say we should look for this. They say what is distance traveled and displacement. So what is distance? Add them directly together. Scalar quantity, we add them directly together. So 4 plus 3 will give us 7. Right? So the distance, so the distance is what? Is 7. What about displacement? Displacement is a vector quantity. So you cannot just add vector quantity together like that. Then we are going to add them. There are different methods of adding vectors. Parallelogram method, Pythagoras theorem method. So this one, since these two vectors, they are perpendicular to each other, we use the Pythagoras theorem method. Okay, so this is y, this is x, right? So it's very easy. Arrow bracket open, y square plus what? S square. That is just it. So arrow bracket open. Okay, what am I saying? Arrow bracket. Arrow equals to root y square plus s square, right? Yes. So arrow equals to square root. What is y? Our y is what? 4. Right? All square, then plus our s is what? 3. All square. Square of 14 is 16. Square of 3 is 9. 16 plus 9. I think that is okay. 16 plus 9 is 16 plus 9 is 25, right? Yes, so everything will be 25. So the square root of 25 is what? 5, right? So the displacement is 5. Distance is 7. So let's go to the option. Let's look for, so our answer will be C. Okay, distance is 7. Displacement is what? 5. So the answer is what? The answer is C. Okay, very easy. Okay, yes. That's 16 plus 9. That is, I think that is 25 now. Yes, 16 plus 9 is 25. So yes. So answer is C. Now let's go to question 9. A particle has, this is under resolution of vector algebra, so it's still easy, very very easy. Okay, so find out that vectors is very easy. So a particle has velocity 1, 2, velocity 1, inclined at an angle of 0 degrees. So the velocity, this vector is inclined at 0 degree. Then 2, inclined at 60 degree. Then 3 root 3, vector 3 root 3, inclined at 150 degree. Then 4, vector 4, inclined at 300 degree. So the actions look for what? Find the resultant velocity in magnitude and direction. Look at magnitude of the resultant and the direction. So very easy. Same thing we did earlier. Y then x, right? Y as this, s as this. Remember, y is always sine, s is always what? Cos. So that's just it. So we start with this one. We start like this: 1 sine 0, right? So here will be what? 1 cos 0. Then we continue. 2 sine 60, okay, plus over here. 2 sine 60, here will be plus 2 cos 60. Okay, plus 3 root 3 sine, how many? 15 degree. This one will be plus 3 root 3 cos 15 degree. Then this one will be 4. This is 300 though. 4 sine 300. So plus, so will be what? 4 cos 300. So look at our s. Able to go. So let's do it. So 1 sine, let's use 1 sine 0 plus 2 sine 60 plus 3 root 3 sine 15 plus 4 sine 300. So our answer is minus 0.387. Okay, our y is minus 0.387. Okay, yes. Okay, now let's do x. Okay, our x. So if you look at it, our y is negative, right? Yes. No, let's do our x. 1 cos 0 plus 2 cos 60 plus 3 root 3 cos 15, right? 3 root 3 cos, okay, thank God, is 150 Thank God I remember early. It's 150. Okay. So it's clear na 150 degree. Thank God. Thank God I realized earlier. 150 degree. Okay. So okay. Plus 3 root 3 sine 150. Okay. So it's 150, not 15. Okay. So plus 3 root 3 cos 150 degree. Okay, yes. So I realized earlier. So let's do it again. So let me do it again. Okay, let me start with this part. Let me be fast. So 1 sine 0 plus 2 sine 60 plus 3 root 3 sine 150, then plus 4 sine 300. So I want to say 0.866. Okay, so 0. Why is 0.866? Okay, 0.866. Now what about x? Let's do it. Okay, so for our x, it will be 1 cos 0, 1 cos 0 plus 2 cos 60, then plus 3 root 3 cos 150, then plus 4 cos 300. So our answer is x is minus 0.5. So our y is positive, our x is negative. So what next I'm going to do, we look at our result, right? R is equals to root y square plus s square, right? Yes, so let's do it. Okay, so let's continue. R root. So our y is what? 0.866, right? All square, then plus our s is minus 0.5 all square, right? Yes. So let me just do it straight. Let me just do it straight and get our arrow. Okay. Yes. So let me just do this. So root bracket open 0.866 bracket close all square, then plus bracket open minus 0.5 bracket close all square. So our answer is 0.9999. Arrow is equals to what? 0.999. Now approximately what? 1. So 1. So the answer, our resultant is 1. So where is the question? Yes, our resultant is 1. Okay, 1. Well, now then we are looking for what the direction as well. Now if you look at it, our y is what? Our y is positive. Our s is what? Is negative, right? Now if you draw that 4 cardinal points, this is positive s, positive y, negative s, negative y. Our y is positive, our s is negative. Positive y, I'm coming. Positive y, negative s. So let's say that our resultant lies in what? We are in the second quadrant, right? The second quadrant. Remember, in second quadrant, to look at the direction, it will be 180 minus yes, 180 minus, look at second quadrant is 180 minus the inverse of tan y over x, right? If it's in the third quadrant, it will be 180 plus the inverse of tan y over x, right? If it's at the fourth quadrant, it will be 360 minus the inverse of y over x, right? If it's at here, it just be theta will just be the inverse of y over x, right? Yes. So it's at the second quadrant. So the angle, the direction of the vector of the resultant will be what? 180 minus. So 180 degree minus the inverse. Our y is what? Our y is 0.866, right? Divided by our s is 0.5. So if we do everything, we get the angle. Remember, our resultant is 1 already. Now let's look for the direction of the resultant. So let's do it. Let me just do it straight. So 180 degree minus shift tan 0.866 divided by 0.5. So our answer will be 120 degree. So the resultant, the angle, the direction of the resultant, the angle is 120 degree. Okay, yes. So the angle is 120 degree because where the resultant lies in the second quadrant, right? Yes, and in the second quadrant, 180 minus the inverse of tan y over s. So that our resultant is 1. The direction of the resultant is 120 degree. Then let's do this last question. Question 10. Okay, so these are the places. Yes, so these are the places we expect question from. Yes, we ask you like resolution of vector, yes, this and this, then this one as well, okay? And please, okay, please, if I'm not subscribed, please do, okay, subscribe, okay? Now let's continue. That is question 10. I said determine the magnitude of the resultant of two displacements, A. So this one is very easy, okay? When you see this type of question, it's very easy. Just do like this, okay? Yeah, it's very easy. So what are we going to do? A is what? Our A is equals to 5i minus 2k minus 2k bracket close. Then our B is what? B is minus 3i plus 4j plus 6k, right? Yes. So how do you solve this type of question? Because it definitely come in your exam. How do you solve this type of question? It's very easy. We had all the ones the way in the same direction together. We had all of them that one that have the same letter. We had all of them together. We 5i and 3i, 2k, 6k. Okay, it's very easy. So let's do it. So like something like this. Arrow is equals to root. So all the vectors that are going in the same direction, that is vectors that have the same letters, we add them together, okay? So it will be like something like this. Bracket open 5i, right? This 3 has minus, so that's minus 3i. Bracket close or square, then plus okay. J, then is there j in A? There's no j in A, so we'll do like this. Bracket open 0j, then plus what? B just j, 4j all square, then plus this one. Remember this 2k has minus, right? So bracket open minus 2k plus 6k all square. So if you can forget about the letters, okay? So 5 minus 3 will give us 2. So 2 square, then plus 0 plus 4 will give us 4. So 4 square, then plus minus 2 plus 6. I think that is 4. Okay? Minus 2 plus 6. Yes, that is 4. So 4 square. So that is how you do this, okay? All the ones that have the same letter, add them together, okay? Yes. So for 2 square, remember don't forget about the square root too. Yes. So 2 square is 4. 4 square is 16. 4 square is still 16, right? So let's add all of them. Okay, 4 plus 16 plus 16, we get 36, right? So it's equals to root 36. Now remember, root 36 is what? Is 6. So our answer is 6. Okay, yes. So these are some questions. So yes, so this is where you expect question from. Okay, so this is how you solve. Yeah, this is where you expect question from under vector. Okay, nothing else. That is just it. Okay, if you want to watch more, want to because we have done this earlier in our previous class under full calculation of vector quantities. You see where I solve a lot of questions there. But all this, I think all these are enough. Okay, yes. Now please don't forget to subscribe. Okay, yeah. So thank you.